My name is Kim Watson. I work for the German organization Fraunhofer, one of the largest organizations for applied research in industry. I've worked at the Fraunhofer Institute IOSB in the Department of Information Management and Production Control for nearly 40 years. So I have long-term experience with questions of information modeling, semantics, and interoperability at all levels in industrial applications. Semantic interoperability is the transfer of meaningful information in a given context.
Hi, my name is Niklas Widell, and I'm a standardization manager for IoT at Ericsson in the CTO office of Ericsson. Ericsson is one of the leading providers of telecommunications equipment to service providers. We have a comprehensive portfolio ranging across networks, digital services, managed services, and emerging businesses, all powered by 5G and IoT platforms. We see semantic interoperability as an important concept to achieve scale and secure evolution of industrial systems. Actually, semantic interoperability requires standardized information models with open APIs and information management methods at a higher level than the semantics of the network level. So we really need to have something in addition to just the network, right? We need to understand more. And one of the problems here is that every domain has their own information models. And what typically happens when we integrate it, we need to bring them together. And this means a costly integration project. So addressing that is the key concern. Also, if we get semantic interoperability in place, it helps with a wider problem of bringing together the IT domain and the OT domain in the sense that we actually have a structured way of talking about what we mean.
However, no vendor can offer the best-of-class applications in all fields, and standardized generic core concepts and information models are needed to create a platform for what I would call co-opetition. That's a combination of cooperation and competition, that is a competitive but cooperative environment where technology users and providers alike can provide best business value for both sides. In the DX era, all services and applications will be undergoing continuous change. Indeed, they have to be able to change continuously through new forms of cooperation. And these DX costs, they rise substantially without standards for semantic interoperability.
The idea behind Agile system development is to be able to more easily introduce new components from additional vendors, or evolving components, or evolving system requirements in a better way. And by having the framework in place to do that, thanks to semantic interoperability, it helps that process, because it takes away a large part of the cost of doing this. Every time you need to change the system, you need to have a costly integration project. And this is, of course, in addition to the other good benefits that Agile system development brings, or Agile or modern innovation process ways that helps sort of improve system design, like design thinking, lean startup, Agile methods, DevOps, etc. Yes, that is indeed true. And writing bespoke, but the problem here is that writing bespoke translation code for every interaction does not scale. In particular, as systems grow and they evolve over time, and the system requirements thus change, it does not scale.
Yes, and indeed, it's not just a matter of writing glue code. You need to look at your whole design and development tool chains in the overall software development process. This is where semantic interoperability is very useful and also necessary to keep the cost of evolution under control and be able to manage your technologies and the legacy systems and new systems in the overall system. This is where, for example, the concept of a digital twin has become important in modern systems. But of course, a digital twin also relies fundamentally on semantic interoperability between the digital twin and the systems and the IT and OT worlds.